All right, good morning or good afternoon wherever you are, and welcome to our PolarConnect event. Today is November 22nd, 2019. We're excited to be chatting with Educator Amy Osborne and the team in Antarctica this morning. They're going to talk about their work that they've been doing down there, and Amy's going to share all the fun things she's been learning with us. Looks like we have a great crowd out there today based on all the students and classrooms that I see that have joined. Just a heads up that if you are in a classroom or have a lot of background noise in your world, please keep your microphones muted until we have a chance for asking questions and things like that. So let's see. A few things. We do have a chat area, and hopefully most of you have found the chat feature in Zoom. You can use that space to chat with everybody and send your questions. And while we have questions, sorry, I'm doing something also here. When you have questions, just type them in there and let us know how things are going during the presentation. At the same time, you can use that area and introduce yourself and where you're joining us from and how many students. It's just nice to get an idea of who's out there during these events. A little bit of background for you before I turn this over to Amy. So Amy is in Antarctica as part of the PolarTREC program, and PolarTREC is a program that's run by a nonprofit based in Fairbanks, Alaska primarily, but we have staff like myself, Janet Warburton, and Judy Fonstock, who live in other places and work for the organization. But PolarTREC itself is funded by the National Science Foundation, and we put educators, both formal classroom teachers and informal science educators like Amy, with researchers in both polar regions. So we place them with scientists in the Arctic and in the Antarctic. This time of year is our Antarctic expeditions, so we've had several presentations from educators in Antarctica with research teams already, and we have more coming up all the way through February of 2020. Let's see. Okay, I already talked about the questions, but just a reminder, put them in the chat box. Dr. Moran does have access to the chat, and her and Amy Osborne will switch and try to answer questions as they come around. Of course, at the end of the presentation, we will also have you ask live questions if you want, or continue with the chat feature, whatever works for you all. All right, with that, I'm going to turn this over to you, Amy. Please let me know when you want to advance the slides. Otherwise, I'll sit here and be quiet. Let you go.
Sounds great. So hi, everybody. Welcome virtually to Antarctica. I'm here with the research team, and we're going to introduce ourselves in a little bit. I'm really excited you're here. It's really cool to see people from all over the country, including my hometown in Marietta, Ohio. That's really awesome. So thanks for being here. Maybe in some of the classrooms I visited. That's on. So you too. Yeah. Yes. Can you hear me?
Yeah. You started breaking up. So if we'll let you know on chat if you do again, and then maybe turn off your video if it happens again.
Okay, great. So I want you all to kind of imagine the coldest place you've ever been in your life. Sort of think about that. Maybe you've been out in the snow somewhere. Maybe you've just stuck your hand in your freezer and you're like, it's so cold in there. So we're in Antarctica, which is actually the coldest place on the Earth, and it's the windiest place, or it's the coldest continent and the windiest continent and the driest continent on the whole Earth. So if you took a globe and you looked at it, and most of the time you kind of see it where you can see the northern hemisphere and the southern hemisphere. If you took it and put it on the end, on the southern end, you'd see a big land mass down there. and that is Antarctica, and that is where we are. So it's 1.5 times the size of the United States. So it's a pretty big continent, but not the largest continent. And it's in the southern polar region. So that means it's south of 66.5 degrees south, all the way to the South Pole. And the South Pole is there on Antarctica. And it does not have polar bears, but it does have penguins. And it's part of, everybody down here is part of the Antarctic Treaty, so nobody owns Antarctica. Instead, there's a whole bunch of different countries that have all made a group agreement to follow some guidelines, or rules actually, which says there's no military action here, and this place is dedicated to science, and nobody owns it. So that's part of the reason we're down here, and we're actually in our summertime right now, and that really means for Antarctica that it's light out all the time. So 24 hours a day we see the sun, which is a really interesting way to live. So to find out more about what we're doing, or where exactly we are in Antarctica, we'll go to the next slide. So we are at McMurdo Station, which is one of 3 research stations that the United States has. And ours is the largest. We have over 1,000 people here when we're at our largest. We have about 970 here right now. And we are actually located on the station in the Crary Lab. So you can see a picture of the Crary Lab right there. It kind of has 3 sections. And we have a couple lab spaces where we have microscopes. We're in one of those right now. And then there's a big aquarium here too. And that's where we do our research. And then the other place we spend our time is out on the sea ice, which maybe in a little bit we can show you, but it's frozen ocean. So the ocean freezes over for a certain part of the year, and then we go out on that sea ice. And we go to these places called dive huts, where there have been holes drilled into the ice, and divers go in them. So let's find out more about our team. So if we go forward, we have 4 people on our team right now. So I'm Amy Osborne, and I'm an outdoor educator at a place called Nature Bridge. It's located in California, just north of the Golden Gate Bridge. And so if kids out there have ever been to coastal camp in Northern California, you've probably been to Nature Bridge, or the Marin Headlands, or Rodeo Beach is here. So not here, but wherever. So that's who I am, and I'm here as an educator and kind of as an outreach person for a little while, and I'll let the other people on the team introduce themselves.
Hi, my name is Amy Moran. I'm a researcher at the University of Hawaii at Manoa, and we work on marine biology, and we're here studying the ectotherms, and Amy's here with us. We're really, really happy to have her here. And these are 2 graduate students at the University of Hawaii.
My name is Graham Loberts. Like she said, I'm at the University of Hawaii. I'm a PhD student. She already explained what we're doing, so I won't repeat that. But I'm originally from Michigan, but now spending my time in Hawaii.
Good morning, everyone, or afternoon, wherever you are. My name is Aaron. I'm also a first-year student in Amy's lab. I've been working for her for 3 years. I'm actually from Singapore, and I've been studying in Hawaii for like 4 or 5, maybe 5 years. I'm one of the divers here, so if you have diving questions, please enjoy the presentation.
So to find out a little bit more about why we're down here, let's go ahead and go to the next slide. So we have a big question that we're asking while we're here. And our big question is if the changing ocean temperatures will affect the growth and development of marine ectotherms. So an ectotherm, the ecto part means kind of outside rather than an endotherm, and endo means inside. So ectotherms are dependent upon their environment around them for their body temperatures. So they can end up kind of cold, and they can end up warm. Unlike us, when we are always at 98.6 degrees or around that temperature. And so when we're in cold places, we need to put on warm layers to keep ourselves warm. Or if we're in hot places, we take off our layers to keep ourselves cool and keep ourselves at our temperature. So this group is wondering what's going to happen to these animals as the environment around them and the temperature around them changes, as their habitat changes, what's going to happen to the way that they grow. So we can go ahead and go to the next slide. So why are we asking this? Well, because our climate is changing, and as our climate changes, that includes our oceans. So greenhouse gases are in the atmosphere, and as they increase, then the temperature, they trap more heat, and so the temperature is rising, and that also means the ocean temperature is rising, and the ocean actually loves to absorb heat. So even when the atmosphere temperature is rising of the air, some of that heat that's there will also go into the ocean. So that means the habitat of all these animals, the temperature is increasing in their habitat. And so why are we wondering about the habitat of these animals getting warmer? We'll go ahead and move to the next slide. Or why study in Antarctica? Okay, so Antarctica's ocean has remained isolated. It actually has a current around it, so it has water flowing in a circular motion around the continent, and that keeps it really isolated from a lot of things that come in from the other parts of the ocean. And so that means that the animals that live here are living in kind of this isolated, constant minus 1.8 degrees Celsius water temperature. So they're pretty stable, and they've been pretty stable for a while. So they're wondering what's going to happen when that stability gets messed up and changes a little bit. So let's talk about what we're actually doing. So here's all what we're wondering, but go to the next slide and we'll start to talk about what we're doing. So as scientists, we have our big question. And so once we have our question, Amy and the team created some methods to try to figure out what's going on. So they are going out and gathering data and gathering information. So do it is they have to go get these animals. So they're focusing on sea spiders and nudibranchs, which are like sea slugs. They're really different than slugs on land, or are small and kind of gray looking, but slugs in the water can be really beautiful colors, and they can also be bigger and they look all different ways. So the team is actually diving under the ice. So Aaron and Amy are two of the divers, and they dive and they go through the hole in the ice, and you can see them getting ready. They put their fins on and they have dry suits on. It's very cold, so they can't wear a wetsuit. They don't want the water to touch their body. So instead they wear kind of a down that you wear underneath with a suit over it. And that ideally keeps them dry when they're under the water, so they don't get wet. But they do get cold. When they come out of the water, they always are cold, and they like to have some hot chocolate to warm themselves up. But you can see a picture that Aaron took actually of Amy under, you can see all the colors above her, that's the ice with the diatoms in it. And then you can see the spiders, the sea spiders they've been collecting, and they use these containers when they go under the water to put the spiders in. And yeah, they collect them. So what happens next? We'll go to the next slide. So let's see. So how do we gather the data? We measure and record things. So while the divers are diving, actually Graham is like an expert dive tender, and one of our jobs is to make sure the divers are kind of safe. Generally, since we've been here, they're always doing their thing down there with no real issues, so that's helpful. But then when they come up, we'll help them. Graham usually helps them grab their tank, and I usually grab their fins and help them with that. But while they're down there, Graham and I don't just sit around and twiddle our thumbs. We actually are doing things too. So we're measuring the salinity and the temperature and the amount of oxygen in the water. And we write all this down. We have a nice little notebook, and I usually write the stuff, and Graham just tells me what to write, which is helpful. All right, so let's go ahead and go to the next slide. So when we're going out into the field, and so out into the field just means when we're outside. and that's when we're outside getting our information. So we use this big red track vehicle called a piston bully, and that helps us get across the ice. It goes between 7 and 9 miles per hour when we're out on the ice. We have to drive like 4 to 5 when we're in town. It works really well on snow. It's similar to a vehicle people use to groom ski trails and things like that. It's good on the ice too. It gets pretty bumpy for us. And then you can see the collecting container and the flashlight. It's pretty dark once they're down there under the ice in the water. And so the divers need a flashlight and a collecting container. And they also need their scuba tanks so that they can breathe underwater, because humans have lungs, not gills. So we need a way to breathe. And that Kuma stove that you see over there is what keeps our dive huts warm. So you can see the picture of the dive hut. That's the big picture at the top. And it's a little wooden structure, and it has that hole, which it's cold. That's letting cold in. So we need a stove that keeps us warm. And also, Graham here is a master Kuma chef, and he kind of cooks all the food. Usually people make their food, wrap it in aluminum foil, and Graham does a nice job of putting it on the Kuma stove, turning it so it heats really well. And then you can see the yellow container. When we come back up, we put what we found into that yellow container. Cool, so we'll move to the next slide to find out what happens next once we're done outside. So once we're done outside, we bring all of our specimens back to the lab, and you can see Graham and Aaron there. They're looking through microscopes, they're making notes, and they're really focused on the eggs and the larvae of the sea spiders and nudibranchs. So they've taken the eggs and the larvae, and they'll put them in different temperatures, and then they'll observe them each week, right? You observe them once a week? Yeah. So once a week, they look through the microscopes, and they have lots and lots of different trays of them that they're looking at, and they'll write down what stage they're in. And they actually taught me how to do this, which was really fun. And I like to sit there and identify them too. So on the left-hand side of the screen, you can see that's a sea spider beginning to develop. You can see its 2 little eyes, and it has a proboscis. So in the middle, that's how it gets its food. And then on the right, you can see a late-stage nudibranch or sea slug. And the interesting thing is, in this picture, you can see the shell that's on it. But when nudibranchs actually grow all the way up, they don't have shells anymore. They lose those shells. But at some point, they do have a shell, which is really fun to watch too. So let's talk about what tools we use when we're observing. So you can see up in the left-hand corner, that's how we, what I made actually when I first got here, so I would know what the different stages look like of the sea spider, which is up in the right corner, and of the nudibranch, which is the long strip of paper down at the bottom. This also have pictures of the different nudibranchs that we're studying, and we also have a couple of different sea spiders that we're studying. And you can see Amy there in the middle. She actually is using a microscope that has a really cold block on it. And that way, these animals that live in minus 1.8 degree temperatures, usually they can stay really cold when we're looking at them. These are trays that we put them in. We separate them out, their eggs, into different trays. And then there's a picture of Graham is actually looking at it under the microscope on the left. And then we also, so we need a way to change the temperature so we can expose them to different temperatures. So one way is to use something called an incubator. That's the thing that looks like a really big refrigerator. So if you think about your refrigerator in your house, you can actually set the temperature on your refrigerator, but whenever you open the door, the cold gets out and the heat comes in, and that can change the temperature inside. So this refrigerator, or it's really an incubator, has a side door that you can open up, and Aaron's opening it up so he can see what he wants before he actually opens the door where the cold would come out and the heat would go in. And then the one down at the bottom is something that is trying to find the organic weight of the eggs. And they're gonna do more with that back in the lab in Hawaii once they get there. Oh, and Graham's working on the thermoblock, which that creates a temperature gradient. So really hot water comes in, cold water comes in, and then as you move down the block, the temperature of the water is different. And they read that block do you do that every day? Yep. Every day they look at the eggs that are in there, and the larva that's in there, and they also measure the temperature. Cool, so let's move to the next slide. So what the data are telling us so far is that these animals are really sensitive to warmer temperatures, meaning, and one way that one thing that's happening to them is they develop a lot faster. So if you think of yourself and sort of the way you develop over time, it's sort of, you're like, when I'm 1 year old, this is what I'm like, and when I'm, you know, but these animals are, as it warms up, their development is speeding up. And as the water is a little bit warmer than usual. Let's go to the next slide. So the next steps are, the research here has begun. It just started in September, right? Is that when you came down here? And so they just started some long-term experiments. And one thing is to sort of ask yourself, well, if their development is speeding up, then what does that mean for the animal? Is it going to stay the same as it's always been, or is it going to end up a little bit different? So this group's going to be down here in Antarctica for 2 seasons doing their research. And that doesn't mean 2 full years. It just means a season is mainly in September to like February? Yeah, so they'll be here September to February this year, and then September to February next year. And you can see on the map, then they'll go back to Hawaii, and they're going to run more tests in their lab there to find out more information. So that's a little bit about the research, and it looks like a lot of people are asking questions. I'm glad Amy's here to keep typing vigorously to answer them. So let's talk a little bit about life at McMurdo and what life is like here for all the researchers. So again, everybody down here, there's a whole group of scientists and then a whole group of people supporting the scientists to be here, because that's the reason we get to be here. So life on the ice, which is where we spend part of our time. I think we maybe go 4 or 5 days, depending on the week, out onto the sea ice. So as I said, we drive these piston bullies. Usually Graham drives ours. Sometimes I drive ours. Aaron hangs out in the back because he dives and he gets really sleepy. And also I had a chance to drive a snowmobile. We all went out to check out some of the historic sites around here from the explorers that were once here. We did see a penguin as a group. We saw an Adelie penguin, which was really exciting. They're pretty cute and small. And then the team before I got here saw emperor penguins. So if you watched my penguin video I made, you would see the emperor penguins walking around. And then you can see the divers there getting ready to go in. And then we've seen some seals here too, which are exciting. Most of them Weddell seals. And the divers have seen some seals when they're under the water as well. But most of the seals then I get to see are up hanging out on the ice, or their heads might pop up through the dive hole, which is the picture on the right. Its little head popped up to say hello. So let's talk about life actually on base in the next slide. So life at McMurdo, we continue to work here. This team works really long, long hours. And so we're kind of always working, whether we're out on the ice or back here. You can see Graham, that's our aquarium where we keep our sea spiders and nudibranchs. You see Aaron is kind of crunching some numbers there. I'm working on my journals. We do have this extreme cold weather gear that we wear when we're out there. So these big red parkas, and we have these white boots that we wear. Yeah, so that's kind of the work we keep doing back here. And then on the next slide, we'll talk about more, let's see, life at McMurdo. So we do eat food, we have to, and we're really fortunate here that our food is provided for us. So we show up at a place called the Galley. We did put some Jell-O on here because that's Aaron's favorite food for dessert. He's really good at judging how good the Jell-O is each day. There's also a big cookie bin. So each meal there are cookies that you can eat. So I show the cookie thing there. The food is pretty good, but we don't have fresh food very much. So fruit and vegetables and things like that, we don't we don't have very many of them. We get excited when they show up on the airplane. So all of our food gets here on the airplane. And then we also sleep in a dorm. So that's a building that has like a long hallway, and off the hallway are a bunch of different rooms, and there are 2 people per room, usually in the dorms. And Amy and I had house mouse duty one time in the dorms, so that's a picture of us doing that. And yeah, to find out about the people here, go ahead and go to the next slide. So we do get to meet a whole bunch of really fantastic people. Everybody who works here eats together in the galley. And so, you know, the person who cut my hair, I see her around, Alicia. And then the sea ice, we had sea ice training with a bunch of the carpenters who I see all the time. Then down in the left-hand corner is Cece, and she's part of the LIDAR project, which she's they're shooting lasers up into the sky to kind of judge the atmosphere. We did get to launch a weather balloon with this person named Kevin, and that was fun. And then I did some hut guide training, and so we explore the hut from 1902 that Captain Robert Scott built he was trying to get to the South Pole. And then we took a tour of the wastewater treatment plant. So all the waste here has to go off the continent. So our recycling and our composting, and then waste we produce from our bodies all has to leave the continent. And so we learned about that by going to the wastewater treatment plant. That's Beck, who told us about that. And then at the top right is Al, and he talked to us about desalinization. So our drinking water comes from the ocean, and we have to take all the salt out of it. And then in the middle, I actually met someone who lives in the Marin Headlands where I live. Her name is Emily, and she works with the SEAL team, and she works at the Marine Mammal Center. And there are a whole bunch of other people here who really support us. So, and we're learning a lot. We get to learn from everyone, and that's one of the really exciting things about this place is you can eat dinner with someone who works with penguins and learn a lot about penguins. So it's fun to ask a lot of questions. So let's go to the next slide, which I think is just kind of thanks everybody. Yeah, so thank you to everyone. The National Science Foundation is who provides the money for us to do this work. This amazing research team has been really welcoming and nice and fun to work with.
Well, you're starting to break up, Amy. We just heard all them.
I'm sad to leave them. I'm supposed to leave on. Oh, okay. My internet connection's unstable. Anyway, thanks to everybody there. I think I put all their names up there. Everybody who helps McMurdo function, and then PolarTREC, and Bridget and Denise who are down here with me, all of Nature Bridge, and all my family and friends who've been so supportive of this amazing adventure, learning adventure to Antarctica. Yeah, we'll take your questions in a moment. And we have some animals we'd love to show you in the outdoors, but I'm sure you have a lot of questions too.
All right. Very good. So there were a lot of questions, and I know Amy is back there typing away, but Amy, is there anything you'd like to now verbalize so you don't have to actually type? And I will stop sharing my screen so we have a bigger view of you.
Yeah, I'm sorry, I was trying to keep up with all those great questions that you were asking.
Can you, Amy? Amy, can you come closer to the, yeah, we need you to come closer to the microphone. Thank you.
We were trying to keep up with all those great questions you were asking. There were a lot of questions about climate change, and I don't think I answered them very well when I was trying to type madly. Things were right where we are in the Antarctic. Things haven't warmed up really measurably, at least as far as I know, from the most recent climate science I've looked at. And people were asking about the ice conditions this year. This year we've had pretty thin ice. It formed late because there were a lot of big storms late in the season. When the ice was trying to form, the storms can blow the ice offshore, and then it has to start forming again, the sea ice. But in parts of Antarctica, in the Antarctic Peninsula, which is the northernmost sort of part of Antarctica, the warming there has been stronger than most other places in the world. So a lot of parts of Antarctica are very strongly affected. Here we mostly see sort of changes in large scale things like movements of the ice sheets. I'm not a climatologist, but that's my best answer to those questions.
All right. I wasn't keeping track of where things were, at like the order, but a couple questions that came up in those last little bit of slides was, Chris wants to know, is it warm enough to compost on site?
You know, I bet my guess would be that a really good compost pile, like my dad used to run, could keep warm here. Maybe not in the dead of winter, but a really big compost pile could probably keep going. They don't compost here. All of the waste is shipped off of continent. It's compacted. Not the sewage type waste is treated here at a sewage treatment plant, and then the water that comes from that is shipped off, is just put out to sea. But all the solids, all the solid waste, all the recycling is shipped back to the mainland U.S.
Okay, and this is a question for Amy Osborne. Is this a one-time experience, or will you get to visit again?
Yeah, this is a one-time experience for me. PolarTREC, the PolarTREC program, fortunately sends us here I was here for 5 weeks. I was supposed to be here for 6, but my plane got delayed. But this will be, yeah, the only time I come down here and work with this team. They're really wonderful. I wish I could come back next year and see what happens as the research continues and work with these amazing people. Yeah, this is it.
Yeah, that being said though, one of the things that's nice about PolarTREC is that we do try to get fund opportunities so that Amy can go maybe to the lab and where the team works and see how some of the data, what it looks like afterwards. And so hopefully they can stay in contact with one another long past this experience. Judy, did you see any other questions? Oh, let's see, Tim is asking, can you outline the long-term study you are setting up?
Long-term study.
Yeah, so the long term, it takes things, we're looking at the early development of a lot of different species, as Amy talked about, nudibranchs and sea spiders. And long term, we're interested in how long it takes them to develop and how the small changes in temperature affect how long it takes them to develop, so the rate of development, and also how temperature changes how they use energy during development. So most of the organisms that we're working on use energy from the egg to fuel their development to the juvenile stage, so that they only have the mom sent off it to develop it. And it's kind of like, you know, if you're carving, you don't do fishing, it's animal with developing at a temperature that's too warm and you develop too fast. I think that answers, hope that answers that question. So our long-term studies, it takes the animals here, the ones we're studying. Some of them we know because we've tested it before. It takes them about a year to develop to the point where they hatch out of their egg masses. Some of them we don't know. So that's another piece of information we hope to find out. I'm going to go back to typing.
Yeah, we wanted to really quickly show you the animals while you're continuing to ask us questions. So I'm going to bring computer over here, but you keep asking us stuff.
Okay.
Yeah.
I have a question for Erin, and my question is, what different places have you dived before? And aside from temperature, what are the differences?
Thank you for that question. That's a great question. I've only ever dived in warm water countries. Like, I'm from Singapore, where it's like 90 degrees all the time. Then I went to Hawaii to study, where it's like 80 degrees all the time. And then now I'm here, where it's like 20 or under Fahrenheit. But yeah, most of my diving has been done in warm water. And that was actually a real challenge for us, because coming down here, we had to be good. We had to be dry suit proficient. So we had to do at least 20 dry suit dives to a certain depth too. So Amy and I were diving at the same spot in Hawaii for over 20 times in a dry suit, and that was hot. So we would go into the water, we would put on our dry suits. In Antarctica, we have a thick layer under it. But in Hawaii, I was wearing pajamas under my dry suit. And when then we go for a dive, when we came out and we took our dry suit off, I would think that my dry suit had a leak because I'm just so wet and disgusting, but it was all sweat. So that is a good indication of how unpleasant it is to dive in a dry suit in hot weather. But over here in Antarctica, when we dive in a dry suit, it just feels great. It just feels right. It's like, this is made for this. Yeah, I don't have a lot of diving experience. Less than 100 dives, actually. Yeah. I don't think that diving anywhere else in the world will prepare you for diving here. Yeah.
And
Wow.
here are some of our stars down here. You can keep asking questions. We're just going to show you. These are our two sea spiders, which get larger here than any other place in the world. Usually they're very tiny.
It's a small little one.
These
are the same. Did you say that again?
Do they bite?
Ooh. They'll bite you if you're a jellyfish. Yeah, but if you're a person, in their proboscis, they have a couple of teeth that they can use to open up like soft-bodied animals. But humans have pretty thick skin. I don't think they're getting through that. They probably try to bite us, but it doesn't work. Oh, if you want to see something that does bite, we do have a giant isopod here. So these we see pretty often while we're diving. And they are much bigger than your regular isopod. You can see they do have the good chompers right here. And if you put your hand underneath, they will bite you. So these are some things that you don't mess around with very much. I'll put it right back.
That is huge. Absolutely huge.
Oh, Graham.
What I'm studying specifically? That's a good question. I mean, I'm really interested in these sea spiders and how they develop. I'm starting to learn more about the nudibranchs as well. But we all work as a team down here, so I wouldn't say super specific yet. It's a specific thing that I'm studying, but I'm really interested in these sea spiders and the nudibranchs that are down here.
Yeah.
What's the largest sea spider you guys have found?
This one right here, that I would say we've seen.
This is pretty close.
Amy said last time she was down here, they had one that was a little bigger, but
this is pretty good.
this is dinner plate size.
That's
So
my bad.
actually dinner plate size. So
I'm gonna leave. So we call this one Scarlet. We don't really know if it's a male or female, but it's really pretty, and it's a very bright and beautiful dark orange color. So that's why we call it Scarlet. And yeah, they get pretty big. They get really big. And in Hawaii, we have sea spiders all over the world. We have them in Hawaii, we have them in Friday Harbor. I'm sure there's lots of them. But the ones that we see in temperate or tropical oceans are maybe like your fingernail size. And then we have the ones here, which are maybe, some of them are like maybe this big. Not that big. They're giant compared to those in temperate or tropical places. And then you have some that are this big, and then you have the giant Antarctic sea spiders, which are like face size or bigger.
yes.
So there's different stages of being a giant.
And are they all the same species of sea spiders or different species?
Different. A
Different,
bunch of different probably
Cool.
five different genuses that we have
Yeah.
out there.
I think that there are 1,200 species of sea spiders in the world.
Yeah.
20% of which are only found in Antarctica.
Crazy. Okay, some questions that came up while you were watching or sharing the creatures with us. Do you release the specimens back into the water after studying them?
Yeah, and I think Amy answered on there, but yes, we do.
Yes, we do. We are only interested in their eggs. So
Okay.
we take their
And
eggs
then-
and we put all them back.
Somebody was asking, why do the sea spiders get to be so big there?
Answer that in. Why sea spiders get big? Okay, I will answer this question. So part of what Amy had been studying on her previous grant is something called polar gigantism. So is this phenomenon where things living in cold water, specifically the two polar regions, the Arctic and the Antarctic, they get really big for some reason. As I was mentioning, sea spiders in Hawaii, like fingernail size. Here, they're like face size. So they were wondering why. And there's a very popular hypothesis, something that people think is happening, called the oxygen hypothesis. And it says that water that's cold contains more oxygen. And when it's cold, the animals have a lower metabolic rate. So they do things a lot slower, they grow more slowly, they just like take longer to develop as well. And so this combination of there being more oxygen and there being a slower like bodily function rate lets them devote more energy to growth as opposed to like breathing or like digestion or like thinking that humans do a lot. And so they have more energy for growth, and that's why we think they grow so big. It has not been proven. Hypothesis.
Okay. And I'm sure Amy, Dr. Moran is probably answering some of these, but from Gigi Educator, does the McMurdo Station team up to research with other countries?
Yeah, actually, I just saw a presentation the other day where we were with the British Antarctic Survey, and they have teamed up with some of the United States researchers to look at the melt of glaciers, and they're kind of focused on where the glacier goes meets the ocean and is an ice shelf, and they're trying to figure out the rate of melt from underneath the glacier. So that's a group of British scientists teamed up with a group of United States scientists. And I also have a feeling we team up with the New Zealand crowd. We can walk to New Zealand, the New Zealand base from here. So, and I see people from the New Zealand base over here, but I don't know that for sure. Do you know other countries that we team up with? I know we do with the British, and I imagine we do with the Kiwis.
We do team up with many countries.
Yeah. I think they are saying, the team here says there are many countries that we probably team up with because we're all over the place.
All right, let's see, from Chris, I think this is going back to spiders. Does a slower growth, Amy just answered your question. Never mind. Amy and I are going over each other here. Okay, how long do sea spiders live? Lauren wants to know.
Good question.
We really wish we knew, because a lot of people ask that question. We don't know because the sea spiders, as far as we know, don't keep any record of years. They don't have any hard parts that we can use like tree rings to see how old they are. So we don't know. Wish we did. Maybe very old.
Okay, and I think you and I caught up between you answering through the chat and me answering live there. I think, we got a new one from Judy. Says, do they sea spiders, do they shed their exoskeletons like lobsters? I think you're,
Yeah, they do molt.
That's really cool to see when we're watching them go through their developmental stages, because you can see them pop out from much smaller sizes into something much bigger. So they really go from being something small to being really leggy, pop out.
And I just want to put it out there that if you have students and want to ask your question live, you certainly can. You can just turn off your microphone. Right now, Meredith is asking, will Amy O bring home any souvenirs?
Sure, I can bring home souvenirs I buy at the store. So similar to other places like national parks, we don't take anything that's not something from the store out of Antarctica. So I leave all the rocks, even though they're really cool igneous rocks here coming out of the volcanoes and things like that. But yeah, so to be honest, the New Zealand store over at Scott Base is the superior store. So our store is good, and they're getting.
Oops, you're breaking up. We heard something about your store being good.
But I've got some good stores. That's where we get our stuff. Gift shops, sort of. And they have other stuff in the store, like snacks.
All right, you broke up a little bit when you were explaining the stores, but I think we got that the Scott Base one was good. Emma wants to know, where do you get your electricity?
Just answered that one on the
Oh,
chat.
okay.
Oh, yeah, when we get it, there's a combination of diesel generators and wind power.
So yeah, as you pull in, once you get off the airplane and you're driving to the U.S. McMurdo Station, you'll see the wind. What is my? Not windmills, but the
Turbine.
Turbine. There we go. Early.
Violet from Goga wants to know, are the animals treated well? What do you do to make sure they're taken care of?
Amy's typing this one in, but I guess I can answer some of it. We try to make sure that they're really cold, so we have water flowing constantly into the tanks, and we like to throw in a jellyfish every once in a while to make sure that they stay happy and their bellies are full, and try not to pull them out of the water for very long because they do breathe through their legs. They get a nice shot of oxygen when they come out. So we try to keep them cold and fed. So they seem to be happy. They're running around in the bottom of the tank like, there's no issues. So.
Okay, and that spurred a question for me. You just said they breathe through their legs. What? How does that happen?
Okay, so they have pores running down their legs, and the oxygen diffuses across those pores into their bodies, and that's how they breathe. So
yeah, so they don't have gills and they don't have lungs.
Very simple but very successful body plan. So
I guess that is fascinating. Okay, Jennifer wants to know, when was McMurdo started? So this might be Amy. I don't know. Who has the answer?
Yeah, so after, it was sort of a post the height of the Cold War time, I believe. So for the people who are in the Marin Headlands, how is the Nike missile site? And that was around the 1950s that kind of was sort of the height of that being there. So the military was down here. So at one point there was military down here, and then that kind of all ended. And the Antarctic Treaty, I'm trying to remember which year it started, but I think it was the late 1950s, maybe. Yeah, 58, 59 is what we're thinking, sometime in there.
So this brings up a good point for our audience. On December 1st of this year is when they celebrate they call it Antarctica Day, and they celebrate the treaty for Antarctica. And we will do a special PolarConnect all about the Antarctica Treaty and how it has impacted science down there. So hopefully our audience will tune in for Antarctica Day presentation, again from McMurdo. So that's a good one. And maybe, Amy, would you like to explain your answer about the colors? There was a question. I was going to ask that, and typed it in.
So yeah, sea spiders come in these sort of, Amy typed it in there, these different colors, sort of shades of red, yellow, orange together. And yeah, they're smooth and they're really light. So if you pick up a sea spider the way that Aaron and Graham were picking them up earlier, you almost feel like you're not picking up anything. But they're really beautiful. And one of my favorite sea spiders to look at is the Colosendus megalonyx. Did I say that properly? And it's like a striped sea star that has like orangish and yellow. And we had one, I think they were showing you one earlier. So it has the orange and the yellow. And I believe, if I'm correct, when it's really orangey and the legs of the female, those are the eggs of the sea spider. So you can see it like up here in their legs, really orange color. Those are its eggs.
All right, we have a lot of fun questions going on about Antarctica and McMurdo established. And it says, Mom, what year was McMurdo established? We can't remember, and the internet is slow. And then in the meantime, there's people that have responded to that. And it looks like it was signed December 1st, 1961. And Kay says, thanks, Wikipedia. Like I said, we will definitely have an event, and I can share, there's been past events about Antarctica Day, and there's a whole website. I'll try to look it up while we're still online and post it in chat that allows people to participate on a global scale in Antarctica Day, and it answers all of these questions that have just come through. There are a bunch of people that are trying to sign off now and are saying thank you. So I do want to kind of wrap it up a little bit here. Lauren says, thank you so much. We got to head out and we love you. Meredith says, this is an amazing opportunity to see Amy O doing her thing, teaching and learning. Keep up the good work, Amy. Much love. Armando saying, thank you from his world. Concise presentation and to the point. And yep, lots of good kudos coming through the group chat right now. Yeah, so I'll take a moment to say thanks to the team for a wonderful webinar, very informative. If anybody still has questions about this really fascinating work, please keep posting and sending your questions to Amy so she can respond to them in her finite time left in Antarctica. When did you say you were headed off again, Amy?
I'm supposed to leave on Tuesday. The planes aren't flying right now, so so who knows? But I think by maybe today or tomorrow they're going to start flying again. So we'll see what happens. But as of right now, I'm headed back to New Zealand on Tuesday, and then on November 30th, I think I fly back to the United States. So I have a little bit of time in there in case something happens, and if nothing happens, I'll hang out in New Zealand for a little bit.
All right. I'm going to let the virtual world open up their mics and say thank you and goodbye to you.